Gradient of a line. The gradient or slope of a straight line measures its steepness in direction. Let us consider this straight line from the diagram below. Given the points A as x1, y1 and a point B as x2, y2, we can use these 2 points to determine the slope or the gradient of this line. But from the definition of gradient into bracket m is equal to change in y all over change in x, which is again equal to rise over run. So when we're talking about rise and run, we're talking about the change in the y1 and the y2, which is the rise, and the run is going to be the change in x1 and x2. But to find the change in the y, it simply means that we're going to find the distance between y1 and y2, or being at y1 and y2, what distance are you going to get between those 2 points? That is what is termed as the change in y, and that change in y is actually going to be equal to y2 minus y1. So assuming this place is this y1 is 2 and then the y2 here is 4, then the change in them is going to be 4 minus 2, which is going to give us what? 2, right? And then we then have the run, which is the change in the x, and then the change in x is actually going to be the difference between the x2 and the x1, which is x2 minus x1. Okay, so from these we can see that m, which is the gradient, is equal to y2 minus y1 all over x2 minus x1, right? So simply that is the formula for calculating the gradient of any straight line which passes through 2 points. So it is observable that A and B are points on this straight line, right? Now if my gradient, my m, is greater than 0, that is where we're going to have such line in this particular diagram, where the line moves, upwards to the right, that is when the m is greater than 0. But if the m were to be less than 0, then we're going to have my gradient, the line on my gradient, to look like this, look like something like that. So it will run down to the right. Okay, in this scenario, if I were to be having something like that, yeah, and then so this particular line, given these 2 points, if my m is going to be less than what? 0. Okay, but for now, what we have to take note is that given the gradient of any line, we just need 2 points in order to find the gradient of any line, and the formula for finding that is m is equal to y2 minus y1 all over x2 minus x1. So we found the gradient of a line that is steepy. But let us look at a scenario whereby we have probably a vertical line. Okay, so assuming that a line is not slopey as we have above, but now my line is vertical, what's going to be the gradient of such line? Considering the formula for the gradient, which says that m is equal to change in y all over change in x. If I want to change in y, it is very easy. That is going to be y2 minus y1 as we have in above, right? Or I can just use the points from the line. We have probably point A, which is x y1, and then we have point B, which is what, x y2. So my change in y is going to be the y2 minus y1. Okay, so y2 minus y1. But let us look at the x. You know, we do not really have any change in x, because the x at this particular point, the coordinate of my x is just x. When I go to the point B2, the coordinate of the x is what, x. So actually, if I subtract this y1 from the y2 to get a change in y, and if I'm looking for the change in x, I'm going to subtract x from x. But you know, as I said, this x is the same x on both point A and point B. So assuming this x is 2, then at point A, the point B2 is going to have 2. I don't know if you get what I mean. This x is 2. Then at point A, the x coordinate is going to be 2. At point B, the x coordinate is also going to be what? 2. And 2 minus 2, you know, you're going to have the y2 minus y1, right? And you see that 2 minus 2 is what? 0, right? 2 minus 2 is 0. So because of that, there's going to be an issue over here, because s minus s is going to give us 0. But according to fractions, anytime that we have a over 0, then we say this is what? Undefined. This is undefined, right? And you see that y2 minus y1 over 0 is a fraction, and we cannot have the denominator to be 0, right? So because of that, we're going to conclude that the gradient of a vertical line is undefined. Okay, yeah, because there's no change in the x, right? Now again, I want us to look at another scenario. What if we have a horizontal line? Yeah, this time around we do have a horizontal line. We want to find the gradient of that horizontal line. So we can have the point A again, which is having the coordinate x1, y, and then we can have the point B having the coordinates x2, y. Right. Now, from the definition of the gradient again, we said m is going to be the change in y all over change in y, x. But what's going to be the change in our y? Actually, you know, the y on the point A is going to be the same y on point B. That is to say that if the y is 2, then at the y coordinates, point A, the y is going to be 2. Point B, the y is also going to be 2. So if I'm looking for the change in y, it's just going to be y minus y. Okay? But for the change in the x, which is the run, you're going to have x2 minus x1, right? So just as I was saying, if the y is 2, then at the point A, the y coordinate is going to be 2. Point B, the y coordinate is also going to be 2, and 2 minus 2 is going to give us 0, right? The same thing applies here, as we did for the vertical line. The change in y minus y is going to give us 1. Y minus y is going to give us 0. And then we're going to have the change in x, which is x2 minus x1. But, you know, any number at all that is being divided, whenever you divide 0 by any number at all, you're still going to get the same thing, because what it means is that you have 0 items that you're going to share with some particular number of people, but you have 0 items. That's what this means. 0, you're going to divide it to some particular number of people. If you have nothing, then you cannot give anything to somebody, right? So 0 over anything is going to give us what? 0. Okay, and for that reason, you're going to conclude that the gradient of a horizontal line, the gradient of horizontal line is 0. Okay, so quick revision: the gradient of any given slope, any line that is steep, is given us by the definition of the gradient, is giving us y2 minus y1 all over x2 minus x1. And when the gradient is greater than 0, then your line is going to stay upwards to the right. Okay, but when your gradient is less than 0, then your line is going to move downwards to the right. Okay, like this one where we have it, see, it's moving downwards to the right. That is when the gradient is less than 0. But if it is greater than 0, your line is going to move upwards to the right. Then we came to the vertical line, where we say that there's going to be no change in the x, hence our denominator is going to be 0, which is going to make our relation undefined. Hence the gradient of a vertical line is what? Undefined. Then we came to the horizontal line, where we saw that there's going to be no change in the y coordinate. So the change in y is going to be 0, and 0 over anything is going to give us what? 0. And we therefore conclude that the gradient of a horizontal line is 0. So in our next video, we're going to look at some application of the gradient. Thank you.